So again, we have our problem geometry set up here, stuff we need to calculate. We've created our spatial distribution, computed the dx, and then now this stuff below is going to be all new. So first, before we get into it, there's stuff up here at the top that you need to keep track of. Python works by importing libraries. I don't know how much I've talked about this, and I think some of you know it. But Python works by importing libraries. Those libraries give you the functions that you need to run. So if I were to come in here and say, like, OK, give me a vector of zeros, it doesn't know what zeros is. Like, it has no function for that. You have to import it and tell it what to do. Hopefully, in the examples I've given you all that, you can just kind of use it and copy from the examples. But just so you know what's going on. So this function, sparse allocation, or spalloc, and zeros, those are imported from this library, scipy.sparse. All right. NumPy gives you this vector zeros. Math gives you a bunch of stuff like pi, cosine, sine, all that. But in order to solve these linear algebra problems, you need to include those import statements at the top of your function, or at least before you use them. Otherwise, Python's not going to know what you're doing. All right, and again, just like copy what I have done to start until you really understand it, then you can change it. The other thing that you need to do is have some plotting functionality. I think you guys have done that now with the homework. In case it's unclear, what we're doing here is we're importing this matplotlib toolkit and giving it a shortcut name called PLT. And then whenever we refer to that longhand name, we can just use the 3-letter PLT instead. OK. So what we're doing, we're going through discretizing the domain. Now we need to set up our matrices down here. And this, like I said, this is the new part. So the first thing you have to do is you have to tell the program how large the matrix is that you're going to be using. To do that, we have this function called spalloc. Actually, it's called, what is it called? LIL matrix, Lil matrix. It's like the wrapper of matrices, I guess. But in MATLAB, it's called spalloc, so I just converted it to that, right? So just for the sake of consistency. So we have spalloc, and then you have to give it the dimension that you're going to use. So it's going to be inside this, these braces you're going to have, or parentheses, you're going to have the size of the matrix, n by n. We should always have an n by n matrix for these problems. Then you need the b vector, so that's going to be zeros of size n, right? So now we have our A and B matrices set up. Now you can assign values to those matrices, right? Now it knows how much space to save for what you're doing. So we come in for node 1, and the first temperature, which is the first node, right, corresponds to the 0 index. It's a 0 index language. So 0 is the first position in the matrix, and then the first row in the matrix, and then the first column is the first variable. So this coefficient here corresponds to T11, right? Or T1, right, in equation 1. This is our T2 in equation 1. That's the coefficient for T2 in equation 1. And then this is our remaining constants for that equation 1. Right, so this is our setup for equation 1. We're just filling in all the constants that we know from our manual solution. We'll go through and we'll do the same thing for the internal nodes. Now we have to do this for I minus 1, I, and I plus 1. Again, this should exactly match what we came up with in Maple or by hand. Our B, and we're doing this for I in the range, not 0, right? 0 would be the first. 1 is the second in Python. So we're from nodes 2 up to n minus 1 not inclusive, right? So when you use this function range, it's saying I'm going to start I at the value 1, and I'm going to go until this condition is hit, and I will stop. So once n minus 1 is hit, it won't execute, meaning you're actually stopping at n minus 2. OK, hopefully that makes sense. Trial and error is the best way to figure that stuff out. OK, node n here. So we have our 3 sets of equations that give us the first ith and n nodes. And now we're ready to basically invert the matrix. All right. In MATLAB, that's pretty easy. You just call this SP solve. We're in Python, so there's one small trick to deal with, which is this A matrix that we declared has to be converted to a certain format for the SPSolve function to accept it. Don't ask me why, it's kind of annoying. But it's this, so just copy this and say it's A dot to CSC, and it converts it to the right CSC format that it needs. I think it's because we're using a sparse matrix, and this SPSolve is a general matrix solver. So it has to convert it to the right, sparse, the general matrix form. All right, so you do this. SPSolve then returns A, the A inverse times B, and gives you back your temperatures, right? So we just solve directly for temperature right here. So it's just as easy as that, right? We go through this whole process and come up with a temperature solution if we have been careful about getting the right indices. So if I can run this, creating a plot of x versus, or temperature versus x. We should see that. Execute in the current console. Oh, yeah. Plot, so that should show up here. Right, Spider. If you're using VS Code, it should pop up for you, but Spider does it this way. All right, so here's our solution. Like, this should look like what we did last time. It should look exactly like what we did last time. All right, this gives you exactly the same solution as ease will give you with numerical precision error, whatever. But it should be exactly the same. We've changed nothing except for the method that we've used to basically invert the matrix. Like, ease inverts a matrix for you. It just is doing it behind the scenes. We're doing it explicitly here, so we can control the process. Okay? Questions on this? Okay. Again, this example and all others are on the Canvas and the files page. So start with this when you're doing your homework. It should help you out.
So if that's a general matrix solver, converted sparse matrix back to general format, are we taking advantage of the sparse matrix even then?
Yeah, so the CSC is still acknowledging the fact that it's a sparse matrix. It's just the LIL matrix format that we use is one of several possible ones that you can use. This particular function just happens to require that format. So it still will acknowledge the fact that it's sparse. Yeah, if you try to go through this and solve it with like a non-sparse matrix, it actually takes a long time to solve, even for a problem like this. So the fact that we have sparse matrices is good. Like, we like that. We just have to handle it properly. Okay. Okay. Let's see. Back to this. Okay. We now have a method for dealing with matrix inversion. So you can come up with a matrix, invert that matrix. The matrix inversion process gives you the exact, or immediately gives you the temperature solution that you need. Yeah.
In the Python,
yeah.
When you inverted the matrix, you did it like in the step to solve for t. So in a way, you don't have a variable in there that's a matrix that's inverted.
So what this SPSolve function,
yeah.
like when you define a function like this, you'd say def my function. It's going to return something, right? And it could return anything. This particular function happens to return the t inversion matrix. It returns from that function the inverted array, and it sort of like swaps itself out for this, and then you assign t to be equal to what it's returning. Is that what you're asking, or no?
No, so, sorry, is that okay?
Yeah, go ahead.
It looks like the inverted matrix will be within the function only, and then returns the solution.
Yeah. So like you don't have a -1.
Yes, right. You are this function is solving the system of equations and returning not the inverted matrix. Yeah, it is the inverted matrix times b, which is the solution. Sorry if that wasn't clear. Yeah.
Is there a way to get the inverted matrix out of that?
There could be. I'm sure there is, but you'd have to Google it. Yeah. Stack Overflow, right? I think about half of my knowledge is outsourced to Stack Overflow. So, okay.